Hello everyone. Thank you for taking the time to join us today. My name is Justin Raczak. I'm a Senior Program Manager with Microsoft. In this webinar, we're going to look at the evolution of the software development lifecycle, outline how high-performing teams are working in the new world, and introduce a conceptual model for evaluating your team's mobile development practices so you can begin charting a course to become a top performer yourself. You can ask questions throughout the webinar by typing them into the discussion box. Let's get started by setting some brief context with a recap of how software development has changed. Not so long ago, we believed if we spent a lot of time working on our requirements, gathering feedback from stakeholders, revising, gathering more feedback, revising again, we would be able to get our requirements into such a state that they would guide us to shipping the perfect software at the very first release. We eventually learned that it never really quite works out that way. Despite the high upfront cost of extensive and detailed requirements and the approval of all the people who had bought into them, we learned from real end users that we simply get some things wrong. Today, mottos like fail fast are commonplace, and we're encouraged to learn what our mistakes are as quickly as possible. But in a paradigm where so much investment has gone into planning that work, it wasn't so casual to get things wrong. So, how do we make it acceptable to get things wrong? We reduce that upfront investment and favor shipping real software to users early and often in the name of learning our mistakes as quickly as possible. Doing this requires a complete departure from the old way of thinking and moving to a mental model of continuous learning and validation. So, continuous learning. What does that actually mean? We think of the cadence for shipping software in terms of feedback loops. By this, we mean the process of developing new software, distributing that software to some user group, observing its performance in the wild, evaluating our observations, and iterating based on what we've learned. This creates a cyclical flow of insight that feeds back into the development process, helping us move our products toward where we want them to be. When we think about what it means to be a high performer in mobile development, the name of the game is shrinking the size of these loops, or the time it takes for an entire loop to be completed. The shorter your feedback loop, the faster you can incorporate new learnings, the faster you ship winning apps. The transition to this way of thinking has been referred to in many ways, but the most popular is one of most likely have heard: shift left. The problem with the picture this phrase creates is that it doesn't capture the essence of what this transformation is really about. While shift left looks at activities as static phases in a linear process that simply need to be rescheduled, what we're talking about is a fundamental shift in how we think about getting work done and why we want to ship early and often. When we think about building and shipping high-quality software often as a means of learning and improving, the model looks something like this. Note that testing begins with development and continues alongside it. We view testing as part of the development process, not something complementary to it. When we build new features, we're testing them. When we change existing features, we're testing them. When we redesign the UI, we're testing it. By following this philosophy, we know our software is always in a good state and ready to be deployed to our users. This confidence frees developers to focus on delivering new value and can help avoid the cost of context switching, since developers are not circling back to fix bugs with code they haven't worked on in months. As we move along, we cut releases of our apps as frequently as possible so we can learn about the changes we've made. To visualize this, I like to think about app releases like satellites. Once you've launched one, it's out there in the world collecting and sending you data about assumptions you've made in the past. High-performing teams have many satellites in play at once, learning from versions of their apps in production, with their beta testers, and even internally with a dog food build. When well managed, this can be a powerful tool that turbocharges the effectiveness of your development efforts. So philosophically, it's great to ship faster. This is something every team can be proud to accomplish. But at the end of the day, what does this really mean for us? What tangible value do we get from shipping faster? Let's use a fictitious example about two movie theater companies to illustrate the point. These two theaters simultaneously decide to build an Android app that allows users to watch movie trailers and buy tickets to the movie from right within the app. Company A ships the first version of their app after 4 weeks. Within just a few days, many of their new users request the ability to pay for movies using Android Pay instead of typing in a credit card number every time. The team incorporates this feedback into the next version of their app, which ships in week 8. Company A sees a 40% increase in conversions after deploying the new payment option. Meanwhile, during week 8, Company B is still in development of the first version of their app. They won't learn about this highly requested feature until after their first release during week 12, a month later. Eventually, Company B garners the same insight and adds Android Pay to their app with the second release, which ships in week 24, a full 16 weeks after Company A launched the feature. During those 4 months, Company A was enjoying 40% more revenue than Company B. In fact, Company A started to earn revenue 2 full months before Company B even shipped, and they shipped the 6th iteration of their app by the time Company B shipped their second. So while this is a pretty generic example, it's easy to see the type of competitive advantage speed and quality brings to a mobile team. It's important to note that while this speed advantage brings value when you're getting things right, it also brings tremendous value when you've gotten something wrong. It reduces the time it will take you to learn that you've made a mistake, correct it, and move on. So far we've talked about traditional software development models and pointed out a few things that high-performing teams are doing today. To understand the changes you'll need to make to become a high-performing team, you need to understand where you are today. To help you, we've developed the Mobile Maturity Index, a framework for evaluating your mobile development practices and charting a course to become a first-class team following best practices. The Mobile Maturity Index focuses on 5 principles we have identified are common across software development teams. While the specific details of execution of these principles may vary, our work with teams across industries and around the world has shown that high-performing teams share strikingly similar approaches. In the following section, we'll step through each of these principles looking at industry best practices and a first step you can take today to begin leveling up. Quality culture defines the way your organization thinks about quality and who's responsible for it. In a mature team, everyone feels they share a role in the quality of the software. You don't hear anyone talking about finding or reporting bugs as someone else's job. Developers think about testing from the beginning and cover their features with automated tests. Product managers or other business people perform exploratory testing from time to time and report any issues back to the development team. Folks from marketing pay attention to comments about quality on social media and relay them back to the product team. Many teams make quality a top-line issue throughout the company, often broadcasting statistics like bugs and crashes on large dashboards in the team workspace. An important first step in making this change in cultural DNA explicit. Use the phrase, quality is everyone's responsibility. Celebrate and commend when teams outside of development participate in finding and fixing bugs. You can host bug bashes or other rallying events focused on quality. The important thing is to experiment and find activities and messages that resonate with your team and get them rallied behind the cause. Your release cadence is defined by how often you ship new versions of your software. Automation has gone a long way to accelerating release cycles for mature teams, and the most sophisticated amongst them are cutting new releases every 2 to 4 weeks. These releases are typically a mix of internal builds, like employee-only dog food builds, and full releases to a public user base. Deciding how often you want to ship new value to your users is the first step in advancing your release cadence. This should typically be based on your organization's goals, but it is important not to be bogged down by the constraints you have today. Even if the people and resources you have available to you now don't support your ideal release cadence, be idealistic. Keep your end goal in mind and be sure you are always working to move forward. This is often facilitated by highlighting the value created by an improved release cadence and then forecasting the results if you were to further improve that velocity. Automation coverage defines the level of functionality in your apps that is covered by automated tests. Similar to logic-based unit tests, mature teams strive for 100% coverage of their app's functionality. This means that anything your user can interact with, or anything that displays dynamic information to the user, should be tested. Any flow a user can follow is simulated and verified by a test. Especially for older or larger applications with lots of functionality, getting to 100% coverage can be a daunting task. You can break this down by prioritizing your tests. Decide which flows in your app are essential and cover automated tests first. For example, If you're an e-commerce app, you might start by ensuring via tests that users can browse products, add them to the cart, and successfully check out using a credit card, as these activities are essential to your business. And remember, as you move forward, avoid creating additional test debt by including automated tests with all new features and code. Your automation strategy defines how and when you are building and testing your app, as well as exactly what and how you are testing. This principle becomes increasingly important as your project and teams grow and resources for these activities begin to feel constrained. Mature teams have organized their tests so that small changes to a branch only trigger a scoped set of important tests, commonly referred to as smoke tests or critical path tests, and usually against a reduced set of device configurations. The goal of this planning is to ensure that code flows freely through the DevOps pipeline and developers are not stuck waiting for results. As you begin to plan your automation strategy, remember that you are designing a system. This means you must think holistically about the net effect of the configuration of any individual point in the system. Setting your pipeline up ineffectively creates technical debt, which accumulates and becomes more costly and time-consuming to fix as time goes on. Always remember the goal of this exercise, keeping the time it takes code to move through the full pipeline as short as possible so your developers aren't stuck waiting around for results. Device coverage defines exactly which device configurations you'll support, with the device configuration being a combination of device model and operating system version. Mature teams take an analytical approach to building their device support list. They routinely review usage data from their analytics as well as any auxiliary data sources available to them to determine what makes sense to support. They'll update this list at least once quarterly, always looking at fresh data each time. Note that it's typically impractical to try to test your app on every device configuration used by every user in your audience all the time. You may want to do this occasionally, but this will likely be as an overnight or weekend build, as testing on so many devices is time intensive. Before you even look at your data to decide which device configurations to support, you should decide on the strategy you'll use to select the devices when you look at the data. Your strategy will depend on your organization's goals, likely tempered with a bit of resource availability. Here are a few basic examples for strategies for selecting devices to cover. First, a very basic approach of deciding a percentage of your user base you want to cover. The percentage of users not covered will give you a rough idea of how many users may be at risk for encountering bugs not found in testing. Another simple approach is taking cues from OS vendors like Apple and Google. Each of these vendors periodically publishes data showing you the share of users running each operating system version. While this can't help you target specific device models, it can certainly help you narrow your OS version focus. And lastly, a slightly more complex example for an e-commerce app. You can map your transaction data to your usage data and ensure that the device configurations that represent the majority of your in-app purchases, let's say about 90%, are part of your coverage matrix. While these are all practical examples, remember that you should decide on your strategy based on your organization's goals. So throughout a few of these principles, I mentioned resource constraints. It's often infeasible or excessively expensive to expand your internal resources past a certain point. This is where cloud services like Xamarin Test Cloud come in handy. This allows you to offload the resource-intensive testing across hundreds or thousands of devices to a cloud service. This also typically gives you benefits of running in parallel, which means you can test your app on hundreds of devices at one time, avoiding long buildups in the testing pipeline. If you've not already done so, you can sign up for a free trial of Test Cloud at testcloud.xamarin.com/register. And at this time, we would open up for questions.